Hi, good afternoon, good morning, and good evening to one and all who are present here for the fifth edition of International Conference on Smart Trends in Computing and Communications. This is session number 3A, and the scheduled time for session number 3A is 10 a.m. British Summer Time to 11:30 a.m. British Summer Time. So if anybody is not of this session, please join the other session. Thank you very much. And to chair this session number 3A, we have with us Dr. Sheng Leng Pang. And before handing over to Dr. Sheng Leng Pang for this session, I would like to just read his brief profile. So he is a full-time professor and director of the Department of Creative Technologies and Product Design, National Taipei University of Business, Taiwan. He received the PhD degree in computer science from the National Tsinghua University, Taiwan. He is a honorary professor of Beijing Information Science and Technology University, China, a visiting professor to Ninzhexia Institute of Science and Technology, China. He is also an adjunct professor of Mansoor University, India. Dr. Peng has edited several special issues at journals such as Soft Computing, Journal of Internet Technology, Journal of Real-Time Image Processing, International Journal of Knowledge and System Science, MDPI algorithms, and many more. His research interests are in designing and analyzing algorithms for bioinformatics, data mining, and network areas, in which he has published over more than 100 research papers. And we are proud to be associated with him for a long time now. It's almost 4 years. And we are happy to have you, sir. Over to you for your opening remarks to start this session. Over to Dr. Pang.
Okay, thank you, Ami, for your introduction. Okay, now I think it's time to get started for this section. In this session, we have, I think, 7 papers for presentation. Each paper has 15 minutes. So I think every paper can have 12 minutes for presentation, and then 3 minutes for Q&A. Okay, so let's get started. So let's welcome the first paper. Okay, right? Oh yeah, yes, sir. The title is a little bit long, so I just introduced the author. Okay, the presenter is Paulos Belinza Sitahen, right? Okay, welcome.
Can you hear my voice? Hello?
Yeah, we can hear you. Okay. Yes, you can start presenting your and sharing your screen.
Okay. Sorry, please. Okay, that's the screen shows. Or it shows. Or
yeah, it's visible.
Okay. All right. Hello. My name is Paulus Belisitohang, and right now I will present about our paper, the Enforcing User Intention of Plan-Based Sensing System Adoption in Public Vocational High Schools of Indonesia using Technological Adoption Models, or TAM. The authors are there's Kandi, Wandari, and me, Paulus Belisitohang from Takao University. Sorry. Okay. As of right now, the development of technologies has been spreading across so many sectors, and he also believes that the educational sector is one of the sectors that is influenced by this high development of technologies. And as of also, we also see that there are so many like the adoptions also we see affecting on the students' performance schools. Sorry. As of right in their scores or in their evaluation based on their weekly reports, etc. And basically, we also would like to see if we could implement or apply one systems, one technological systems into the educational sectors in Indonesia. We would like to see the effect or the influence if there is any. And now about the schools in Indonesia, there are two kinds of schools. There's regular schools that basically they are teach about mostly subjects that like physics, science, maths, and etc. And there's also a vocational school. The difference between the vocational school and the regular schools is there's such specific subjects that is given by the schools onto the students. And these specific subjects relate to the major which the school takes or choose, such as let's say the agribusiness or machineries or informatics, etc. So different to the regular schools, the vocational school subject, there are like computer science stuffs like programming if it's informatics, or if agribusiness, they need to learn about such as the plants plantation or the soil, how soil works, such as like that. Uh, and the portion of the practical and theoretical, this is based on the curriculum given in to the schools based on the government laws. The 60% of the methods or the learning system needs to be in the practical session, and the 40% is on theoretical. This means that the students in vocational school are more into practicing their theory rather than the regular schools, and they are also aimed to be ready to work on any kind of the work environment. This is the one sample that in the school itself, the school in our city, in Bandung especially, one of the vocational school in which majors in agribusiness. And as you can see, they are practicing their studies on about the soils and extra. Now about the system that we applied onto the vocational school itself. The name is Pilstana. It's available on the Google Play Store. So this is basically a mobile apps that capture essential parameters related to agriculture, such as the humidity, the pH, and etc. There will be an image follows about onto the points, and the flows are, as you can see in the image follows. Basically, the system or the object needs to be paired within the phone or any kind of device that the students have. If it's already paired, so they need to select the plans, and then it will update the news data based on the status of the plans itself. And that's how the flows works. This is the image on the device that's the Pilstana itself as a detector or a sensor, I mean. And this is the user interface. As you can see, there is a light sensor, temperature, so moisture, conductivity, and etc. And this is the indicators that is, or the parameters that are counted on the device. Now, about the methodology or the models that we are using for this research, we use the TAM, Technological Acceptance Model. We believe that this model is the best model we can use to achieve on this research. About the TAM itself, it is actually based on the theory of recent actions, which we see that if there are two kind of factors, independent factors and the dependent factors. And we see that these two factors, if is there any influence between these two factors and also the actual system use. Actual system use means that if the person using the system itself has any influence or has any different actions or reasoning towards after applying the system itself. Now, the methodology we use, there are two kinds of methodology we use: theoretical study, in which we are researching through literatures that we find about or the same with our research subject, and also we also do some discussions. And about the software methods, we also use the sampling by questionnaire. The questionnaire itself is given to the one of the vocational schools in SMK in Bandung, our city. The name itself is SMK 1 Cilengkang or Cilengkang Vocational School. The vocational we took about 44 about 50 data, which is 44 data from the students and the 6 data from the teachers that already use or applied the Pirsana. And this is the proposed framework that we create. So basically, there are 3 hypotheses. The first one is on the H1 is the system features of Pirsana, and the Pirsana is the application, and there is a perceived usefulness and the perceived ease of use. And this is the factors that affecting the attitude of the subjects. The subjects we mean is the students. The students will be see if there's any behavioral attention or if there's any difference on the behavior after using the apps itself or the technology itself. We believe that these 3 are the main key to if there's any changes in the attitude. Since we see that let's say the system features of Pirsana, it means that we believe that the features given onto the apps will influence the attitude of the user. The perceived usefulness means the performance of the apps itself will influence the attitude of the student, and also the perceived ease of use means that the easiness of using the apps, of surfing onto the any functionalities of the apps will affects the attitude of the student. And after all, these attitudes we believe will affect the behavioral intention. Now, the results we are doing 2 kind of base of analysis. The first one is reliability analysis. This is needed since we need to make sure that the answer of the questionnaire that we have given towards the students is reliable and also useful for our research. So we do our reliability analysis using Kornblum alpha model, and we found out that the results of the Kornblum alpha model is around 0.736, which means greater than 0.7. The 0.7 parameters means that the questionnaire given is reliable, and we can use the questionnaire for the next step analysis. The next step analysis is the regression analysis, which means that we count based on the hypothesis before, the 4 hypotheses, the system features, the perceived ease of usefulness, and also the perceived usefulness. We group the variables, all of them, into 2 categories, such as the independent category and the dependent category. And the results are as follow, that we can see that the system features of the apps looks higher or the highest among other factors. This means that the subject or the students are basically more likely to feel more easy if they are having the apps having more features on the system rather than usefulness and ease of use. And you can see that also the factors of attitude really gives much uh, action towards the behavior intention. Since it's the score around 0.65, this is the beta score, which means it's the I'm sorry, the score influence shows the influence between the two factors. And the conclusion of the results, we can see that the users has a tendency to pay more attention to the features presented by the application itself. And also, we believe that the system is the pure sana, or the apps that the apps is the key alternatives for practical approach from the student's perspective. We also believe that there is likely to, if there is any, let's say, future works that implementing such as these apps, the apps itself needs to look onto the system features to be accepted by the students or by the students of the agribusiness or similar. I think that's all for the presentation of our research. Thank you. If there's any question, feel free to ask.
Any question? Okay, any question? So may I ask one question? Okay.
Oh,
hello.
Please. Okay.
Yeah. You in your presentation, it is not clear. You present a flow chart, but I don't know. Do you have any data or some example for your this experiment? You in the result.
Yeah. Okay. Oh, actually, we as of before, we have gathered around. Well, I'm sorry, but I haven't post the results since the questionnaire actually in Indonesia, since most of them in Indonesia, but we actually have gathered the data, and the questionnaire to 50 students, and it was, I think, well,
It's okay. It's okay. It's okay. 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 Thank you very much. Thank you.
yeah, sorry.
Thank you. Okay. So for the next paper, the speaker is Burma. Oh, see? Burma. Oh, are you here?
Yes, Dr. He. Good
Oh,
afternoon.
okay.
Good morning.
Yeah, welcome.
Am I audible?
Yeah, you can start. Okay.
All right. Okay. I'll just share my screen. Is it visible now?
Yes, it's good.
All right. Okay. So I shall start now. Okay. So good day, everyone. My name is Bernard Ugalde, and I'm very happy to finally make it here. Before I will start, I would like to acknowledge my co-authors, Dr. Albert Binluan and Dr. Jennifer Carpio. This research is entitled An Optimal Route for People with Ambulant Disabilities Using Mathematical Risk Modeling and Analytic Hierarchy Process. 1 billion of people, or around 15% of the global population, suffer from impairment, while 2 to 4% of them face severe operating issues. These people often are unseen and they are usually forgotten. In fact, individuals diagnosed with ambulatory disabilities remain among the most vulnerable population that warrant great attention as they impact a wide variety of people around the globe. This brought forth to the claim
Excuse me.
that
Excuse me.
nearly,
Hi.
yes,
Uh,
sir.
Can
Yes,
you
sir.
share your slide?
Is it not visible
Yeah, your
here?
slide. Yeah, PowerPoint file
This,
or something. I cannot see your slide.
is it still not visible, sir?
Now it's okay, I think.
Here. Shall I proceed? All right. So I shall continue here. So a point in case is the Philippines, where the percentage of people with disabilities estimated to be 1.57% of the total population based on the 2010 population and household census. In fact, in the same year, the City Social Welfare Development Office of Baguio has estimated the city's overall number of disabled persons to be around 1,400. The PWD in the area comprises 1.2% of the overall population in the city. The growing demand for equal privileges and rights paved way for the government to implement laws and regulation supporting the interests of the people with disabilities. This aim to enhance the overall health and social integration of PWDs in the education, wellness, fitness, leisure, work, and other facets of social progress. To illustrate, disability-related events allowed based on the City Ordinance number 24, series of 2017. Many regulation involves Batasang Pambansa 344, which requires the construction of equipment inside institutions to facilitate the mobility of PWDs. It involves also the Republic Act 7277 or the Magna Carta for PWDs, which allows the process of enhancing infrastructure and increasing the availability of PWD-friendly amenities as specified by the law. Various navigation systems has been conducted to distinguish people with wheelchair from those who relies on others. This also look into the increasing social integration and the effort to defend the aforementioned legislation for the advantage of the PWDs. They vary from studies to core attributes for the creation of assistive location-based technologies to investigation on the concepts and execution of direct tracking mobile application frameworks. However, these systems has some limitations that hinders the movement of the users. It is for these reasons that the proponents wanted to make a difference. A simple gesture of helping turn into advocacy to empower our less privileged brothers and sisters. The research field is abundant, but lacks the application, particularly in the local scope. Thus, the researchers seized the opportunities to develop a system to address the gap between the city of Baguio. The research is also relevant and timely during this COVID-19 pandemic, since it's especially vital for mobility in third person not to be stranded whenever they needed to go out. Our previous paper explored how the graph representation for people with limited mobility could be extracted. The coordinates of 135 PWDs were found, and a total of 168 routes were identified. The Hyversine formula was used to calculate the road distance. The Levin's test and t-tests showed that derived coordinates and distance did not vary significantly from the Google data. The empirical road modeling research indicated the acceptability and the reliability of the generated graph. Thus, this current research tries to optimize the graph, taking into account many convergent factors that affects the selections of the best route. In order to do this, A survey tool was designed to elicit the relevance of the 15 impedance factors derived from the literature review. The mean values of the survey were computed. Subsequently, interview was used to triangulate and verify the result of the feedback. On the other hand, a mathematical risk estimation allowed the identification of the primary factors, establishing the set of all possible independent variables and their relationship that could affect the safety of the wheelchair users. Afterwards, the AHP was used to characterize and rank the highly relevant factors. At this point, there was a need to gather extra information to derive the priorities of the alternative with respect to the criterion. The field experiments, observations, and calculations were carried out. The graph was then visualized with the help of Graph Online. Mnemonics were used because the simulation program doesn't support the coordinates. Sum as the shortest path has been simulated. Thus, the resulting optimized model was then defined. The findings of the survey feedback shows that the 5 highly relevant factors are reflected in this table. This is among the 15 impedance factor identified in the literature review. Alongside with this, the modeling of the relationship between each primary risk factors was based on the standard risk analysis formula as shown in this equation. Risk is equal to hazard times exposure times vulnerability. Thus, the encompassing associated risk can be expressed as the mean accident rate based on the road type, mean accident based on the road width, mean accident based on the elevation of the road, and the distance traveled by the user. So collectively, the established fundamental relationship shared the 5 of the 15 factors identified in the literature review, namely the road length, slope, time, type, and road width. These factors were incorporated in the AHP as part of the hierarchy. The rest of the AHP process were carried out from this pairwise comparison to the calculation of the decision matrix. The AHP revealed that the road slope is the top priority of wheelchair users when navigating around the city, and the least priority is the travel time. These findings share same result with other studies who implemented navigation systems for mobility impaired persons. Based on the previous steps, there were 4 factors that needed to be collected, so the researcher went back and do some more field experimentation in order to collect the travel time, made calculation making use of Google elevation for the slope, observation for the both road type and the width. The data were recorded, sanitized, and consolidated. Along the way, there are some notable observations as follows. Based on the quantitative measurement, the mean slope measured at 4.91 degrees. This implies that the most or majority of the road in the city for mobility impaired persons are elevated. This contributes to the battle of people with ambulant disability when navigating around the city. For them, a planned travel route is a very important task. Based on the field experiment, the average travel time was calculated to 70.39 minutes. This shows that people with ambulant disabilities takes time to propel their wheelchair to reach their destination. The figure shows the different roads in the city. Based on the respondents' report, most of the road identified were sidewalks, and 12% of the total reported RAM were pedestrian lanes. This figure shows the different widths of the road. The respondent reported that 86% of the road was wide, and the remaining 14% of the road was narrow. This supports the claim that the city is keen in developing roads that support traffic in the city. Finally, we got the data we needed, so we proceeded to calculate the final weight. All data were treated using the decision matrix calculated earlier. They were normalized and further processed to derive the synthesized model of the final weight costs. The weight of the edges has been updated based on AHP optimization. The graph was converted into matrix and was used in the succeeding steps. The graph was then tested for a shortest path, and it was able to generate the shortest path. So travel navigation for people with ambulant disabilities is a multi-dimensional task that requires comprehensive knowledge around the surrounding environment. Human thinking style is limited for decision-making to determine the optimal route among several alternative paths considering multiple convergent criteria. This study proposed a model to help people with ambulant disabilities to determine the optimal route for a short and safe navigation. The analysis of the result of this study indicated that among the 15 impedance factors that affect the selection of the best route, road length, width, slope, type, and travel time are the highly relevant criteria in travel navigation with people with ambulant disabilities. The empirical study of route optimization demonstrate the applicability of the proposed approach. Thus, the next step is to develop and code the software application in a form of geographic information system that will capture the optimized graph model. These are the references used in the study. Okay, thank you. And if you have any clarifications or questions, please just feel free to ask me.
Any question? Hello? No? I don't know. Do you have a test with the Google Map? Use the Google Map. I don't know the solution is good or not comparing with your solution.
Yeah, actually, on the initial data gathering that we have, we plan to use Google data, Google Maps as our API. But of course, on the succeeding phases of this research, we'll be comparing it with the OSM, which is an open source data map, and we'll try to see who has the closest estimation based on the actual collection that we have. So we'll plan to do that, but it will come after. So we just laid out our framework so that we'll be ready for the development of the application. So once we have the application, we'll get your suggestion, actually not only for the OpenStreet, but other GIS for mobility impaired person like Wheels Map, Route for You, they are available right now. So we'll see how the system will be at par with these different mobile applications available.
Okay, thank you very much. Okay, thank you.
Thank you for the opportunity.
Okay. Okay. The next paper, the presenter is Dennis. Dennis, are you there? Okay, Dennis.
Yes, I'm here. Can you hear me?
Okay, welcome. Please.
Welcome. I will share my screen now. Do you see my my presentation? The slides are moving. Is good.
No.
Okay. Let me try again. Now is good.
No, still we cannot see your screen.
I don't know why. Let me try again.
Dennis, I think you are still not able to share your screen.
Yes, I only.
So I am making you the co-host of this session, and
Okay.
I'll withdraw the permission so that it will be easy for you.
Okay.
So you are the co-host now. You can share it easily at this point.
Okay, I will try again. Can you see it?
No, we are not able to see you. I'll close this screen also. 1 second.
I will try to.
Harsh, I think you can remove your screen.
Okay, sir.
Yeah, Dennis, now you can try to share the screen.
Okay. I share my screen.
Yeah, now it's
No, you can see it.
yes, we can see it.
And right now, when I'm moving the slide, you can see the movement.
Yeah.
Okay. Good. Hello, everyone. I'm sorry for the delay caused by the sharing screen, but let's start. My name is Denis Tănescu, and today I will present you the paper on the existing and new potential methods for partial discharge source monitoring in electrical power grids. In this presentation, I will address the reasons that were the basis for this work and the theoretical aspects considered. I will also describe the practical application and that was made to support the study and the conclusions we reach after performing this analysis. Power grids are facing an increase in the number of electrical cable used. In such networks, it's inevitable the occurrence of failures that can lead to the problems related to the quality of energy delivered. This produces significant losses for both producer and the consumer. At this time, the existing control techniques for maintenance of a power grid have certain disadvantages. These include the need for authorized personnel to check the line segments, interruption of line or power supply, high computational time in the analysis of collected data, the existence of operating losses and financial losses, and so on. Studies in this area show that the largest losses are due to the electric failures. At the moment, manufacturers have begun to turn their attention to the means of monitoring and the maintenance of these networks, designed to determine and locate such failures. But this determination occurs very late or even when the network is no longer operational. The basis of this paper is the creation of an online system for monitoring and control of electrical network, capable of evaluating such complex network in terms of partial discharge analysis. The dielectric problems in cables generate partial discharges that are transient signals subject to effects of propagation. Moreover, there is the possibility that different external accessories are connected to the network. These loads generate a unique signal that does not produce reflecting additional versus of its own, but since it's usually much closer to the sensor than the partial discharge, their magnitude is much higher. This complicates the process of network monitoring in order to accurately detect the partial discharge source in this network. In this context, the aim of this paper is to study comparatively the state-of-the-art detection techniques, spectrogram and wavelet transform, as well as the new techniques recently proposed, compressive sensing and phase diagram-based analysis. The short time Fourier transform, the oldest and also the most used time frequency analysis method, was introduced to be able to measure the frequency variation of a signal. From the short time Fourier representation, namely the spectrogram, the detection curve is computed, and from here the detection of a partial discharge activity corresponds to the time moment for which the frequency signature of the partial discharge is higher than an imposed threshold. The wavelet transform is a linear transformation used to decompose a signal into an orthonormal basis consisting of a family of functions called wavelets. As a result of this transformation, a two-dimensional function is obtained, namely the scalogram, which reproduces the signal energy distribution for a certain scale and position in time. The detection curve captures the appearance of the signal of interest for which its energy distribution exceeds a certain threshold. Background of compressive sensing, which is a recent topic in nowadays signal processing field, is based on the possibility of obtaining a signal from its incomplete version. In this slide, the algorithm for this method will be presented. Starting from a signal that exhibits sparsity in an orthonormal basis, it's possible to represent it using its first transform domain. Using the compressive sensing approach, it's possible to reduce the sampling rate of the sparse signal with the help of a reduced signal Y. If the number of the non-zero coefficient of the vector is much smaller than the total number of samples, the vector is considered to be sparse. Assuming that we know the position of the zero coefficients, if we eliminate the columns corresponding to them from the compressive sensing matrix, we can create the reduced signal. In this way, we can reach the reconstructed signal having a small number of samples. For the detection curve construction, we assume that the signal is sparse in the short-time Fourier transform domain. Next, the last method is based on phase diagram approach. This method is based on extracting dynamic information about the sequence of values of an input dataset. Its foundation consists in the construction of the phase space of the analyzed system. Phase space is a space in which all possible states of a system are represented, each possible state corresponding to a unique point in the phase space. Starting from a time series, the strategy for the construction of the phase space is given by the transition from the initial values of the time series to a vector that defines the new representation space. In the process of determining the detection curve, the following steps are followed. First, we determine the angular distance between two position vectors. And second, we estimate the instantaneous frequency law of the signal according to the number of points that check the condition for angular distance. In the next session, we will present the experimental application and the results obtained. The electrical network created, observed in the figure, consists of several sections of coaxial cable arranged between three post stations, P1, P2, and P3. It is powered by an auto transformer, and in order to be as close as possible to a real network, a source of partial discharge has been introduced. Also, at post 2, a water heating circuit was connected, and at post 3, a motor, in order to detect their impact. By implementing a simple monitoring system with the help of high-frequency current sensors and data pre-processing and acquisition board, it's possible to achieve both an online monitoring of the network and data collection in the form of electrical signals that, after some processing, will provide us the information we need in order to control the network. In the first phase, the impact of these two external accessories on the network is studied, performing an analysis of the signal transmitted in the network in the presence of the partial discharge signal, as we can see in the figure. Using the spectrogram-based approach, the detection curves are obtained. As can be seen, the signal introduced by the heating circuit has a higher amplitude than the partial discharge, this leading to problems related to its detection. The low level of the partial discharge signal and its reflection make it impossible to detect the fault by choosing an inappropriate threshold. So a prior view is necessary in order to make a decision. Analyzing the detection curve in the case of the motor, its separation from the useful signal is impossible, the magnitude level being the same for the two signals. Using wavelet approach, by determining the detection curve, the existence of local maxima can lead to false detection. Not knowing the shape and size of the signal, there are problems given the choice of wavelet. And in this case, a visual evaluation is needed. There is also the problem related to setting the detection threshold. Starting with our proposed approach, the compressive sensing approach is used in combination with the spectrogram to see if there are any improvement to this method. According to the figure, the process of detecting transients is easier in this case. The detection curves show a lower number of possible false alarms resulting from choosing an inappropriate threshold, but the constraints related to the use of spectrogram remain valid. By estimating the instantaneous frequency loads of the signal using the phase diagram, the time moments of the appearance of the different transients can be highlighted, being eliminated the necessity of the existence of the detection threshold, as can be seen. Depending on the frequency content, a decision can be made regarding the nature of the transient. In order to quantify the information revealed so far, the raw curves were computed, which help us to observe the detection of each analysis method, as shown in the figure. The two proposed methods based on newer concepts bring us a higher performance than the two classic methods. This can make a beneficial contribution to the usual methods of analysis. In this paper, we make a comparison between different methods used to detect partial discharges in an electrical system, focusing on two classic methods widely used and two more recent methods that can be used for this type of application. The major advantages of the two new methods is that they do not depend in their analysis on the shape of the signal, unlike the Wavelet Transform. We also show that the method based on compressive sensing can be used in combination with the spectrogram, so that the level of accuracy of the results is higher. The estimation of instantaneous frequency load is successfully done using the phase diagram analysis by associating time frequency points according to the criteria defined by this method. This highlights the coexistence of signals even in noise conditions. Thank you for your time, and if you have any questions, don't hesitate to ask.
Okay, thank you, Dennis. Any question? Any question? No? Thank you. Okay, thank you.
Thank you too.
Okay. Next paper is related to the visual quality comparison. The presenter is Johnny Zhou, right? Welcome.
Yes, I'm here.
Yeah. Okay, please.
Share my screen. You can't see me.
Hello.
PowerPoint, right?
No, Hashi Sony, can you release your screen?
Yes, I'm doing this one, but in my computer it's showing the screen, but okay.
Thank you.
Okay.
Yeah.
Okay. Hello everyone. My name is Zhou Jiani, and I am a graduate student from the Department of Visual Contents, Dongsu University, Busan, South Korea, and pursuing my doctoral degree. Today, I will introduce my paper to you, which is called the Visual Quality Comparison of Ocean Wave Effect at Different Camera Distance. Let me start. In December 2019, Zhou is me, in ICC-SIT. In other conference, we based on the ocean wave effect made by Houdini, used the text animation texture to import the ocean wave effect into the engine. The goal of that paper was being tested on the maximum polycount number of the ocean wave imported to the engine. No comparison of the similarity of the effect in the two software, only seeking to import the full animation, no testing camera distance. So people only compare the two pictures by looking at the visual and can only roughly explain whatever the two pictures are similar or subjectively say which picture is more in line with his aesthetic. So, and can't get more detailed data analysis. So in my paper, in this paper, we propose that at the certain camera distance, Houdini and engine can achieve approximation that results in shorter final rendering time. We use the render images of ocean wave effect at different camera distance as object of comparison, using the similarity table derived from the image comparison system, which is called SMARTCOM. So as to deride the highest similarity when the ocean wave effects in Houdini are imported into engine, the camera distance value varied, and to restore the Houdini render effect in the engine as far as possible. So in order to compare the quality of the rendering images under a different camera distance at the different software, the first thing to do is to unify the environment of the two software. The default lighting in Unreal Engine is all about reproduction of realistic renderings. It doesn't quite match what we are aiming for as a study. So the visual optimization has to be turned off to produce the more objective results. Even if we clearly know that the rendering algorithm of the two software are different, we try to unify the lighting, materials, and ocean surface so that these have the minimum impact on the render image or maintain the same interference value. So we can say a red grid is created above the sea surface as a reference target. The distance from the camera to the sea surface is defined by adjusting the focus distance between the camera and the reference target. A camera will be set every 10 meters, and a total of 10 cameras are placed. The overall oceans The overall ocean wave effect is 120 frames. When comparing the images, we have the choice frame 110 that shows a large difference to compare the images. It can be seen that at an intensity of 1 for HDRI image, Unreal Engine render is in very high luminance compared to Houdini. And SMARTCOM will compare the images based on their brightness, contrast, and structure, and can get very detailed similarity data. And the rendering images from the 10 camera locations are compared, and the table of the similarity looks like this. We can see the highest value are found at the camera distance of 30 meters to the 15 meters, and the highest similarity of 73.81% was obtained at a camera distance of 40 meters. The similarity of the images decreased as the camera gets further away or closer. As we know, brightness is related to the image similarity, so we need to do more tests. The intensity of HDRI in Unreal Engine was set to 1.5.1.05, 4 values for the test, and shot out the chart. In this table, we can see that a comparison with the Houdini image when the intensity of HDRI in engine is set to 0.1 0.1, it means data 3 is marked in green, which shows that the close to the 80% at the camera distance of the 20 meters. We can clearly see that this line, this green line, is much more similar than other data. So the render images of the ocean surface in the same material and environment was used as a comparison with a similarity is at a high level at HDRI of 0.1 and a camera distance of 10 meters to 40 meters. The ocean wave effects created in Houdini were reproduced in engine with the aim of reducing the time cost. This figure records the rendering time of the 120 frames in Houdini, as well as the import time, generation time of the images in the Unreal. So it can be concluded at the camera distance of 10 meter to the 40 meter, the time saving is up to the 20% of the original rendering time, and the similarity can be achieved at nearly 80%. So the aim of this paper is to test the camera distance and to compare the rendering of the effect input from the Houdini by Unreal Engine at different camera distance. Using the SSRM system image structural similarity system to objectively demand the similarity of the render images and to save the time. During the first comparison, we can know the brightness has a center effect on the final image similarity. So we do some adjusted test, but the brightness adjustment about a limited improvement. So from the original is 73.8%, based close to 18%. We also briefly know that we also briefly sort out the time consumed, although at this stage reduced to 20% of the Houdini rendering time, but the ocean wave effect have many other parts, not just for the ocean, for the surface. So we need to, in the future, we need to focus on our testing on the water material and the form similarity to improve the similarity. So thank you. Here is my presentation too. So if you have any question.
Any question?
Interesting study. Thank you. And I think if any people were asking me a question, just I do some video, just you can see that what's the difference about the brightness have the impact on in the Unreal Engine. Maybe it's just the one small part of my study. So maybe in the future, I will more system about how can get the ocean effect from the Houdini to the engine. It can be very realistic or it's very useful. I just think about that.
Yes.
So
good. Yeah.
Yes. Okay.
No.
If you don't have any question, just
thank you very much.
Thank you very much.
Okay. So the next paper is related to
Professor Bang, there is one announcement that there is one author called Prapti. I think the session is 1B. Sorry, 3B for him or her. So Prapti, it is 3B for you. It is, and we are running the session number 3A here in this session, right? So you have to join the other session. Okay, thank you. Professor Bang, we can continue.
Yes.
Okay. Oh, okay.
Can we continue?
Yeah, Jani, thank you for your presentation. And Professor Bang, now we can continue.
Okay. Okay.
Thanks, Jani.
Yeah. So let's go to the next paper. Okay. It's related to the impure water quality. Okay, so the presenter is Yamuna. Welcome, please.
Good morning. So shall I share my screen?
Yes, you can.
Sir, hope my screen is visible.
Yes, yes, yes. It is.
Okay, good morning, ladies and gentlemen. I would like to quickly introduce myself. Young, adaptable, modest, understanding, neat, adventurous. Yamuna, that's correct. My name is Yamuna and I am a final year computer science student studying at Amrita Vishwavidyapitham, Amritapuri, India. I'm here today to present a paper addressing impure water quality and associated challenges faced by a rural community in West Bengal through sustainable technologies on behalf of our entire multidisciplinary team. This is the outline that I'll be going through as the presentation progresses. To start with the introduction, did you know that nearly 1 billion people in the world do not have access to safe, adequate drinking water? Yes, you heard it right. Most of us don't think about the water we drink. Clean drinking water is a basic human need. Unfortunately, 1 in 6 people lack reliable access to this precious resource, and the problem is particularly acute in the developing world. Water occupies almost 71% of the Earth's surface. However, the supply of the fresh water is nearly 3% of the total available water. Most of it is polluted, contaminated, or treated unsustainably. The situation in India is equally bad. India is considered to be the third most water polluted country in the world. Especially, people living in rural areas are getting by without a decent source of drinkable water. According to Niti Aayog's report 2018, 21 major cities in India will have a shortage of groundwater, which is the main available water resource in India. In addition, the report projected that water demand in the country is expected to be twice the available supply by 2030. Hence, improving water quality to make it safe for drinking is considered a challenge in general, especially among rural communities in India. With this in mind, a study was conducted in an Indian village to promote a sustainable solution to improve the quality of water. And the main aim of the research was to learn the problems encountered by the village community through various tools and propose an app solution with a sustainable technology-based intervention. Under the aegis of the Living Labs program, that is a multidisciplinary experimental learning program that breaks classroom and lab barriers by applying learned theory in real-world settings, a study was conducted in the rural village of Krishnarampur, India. Krishnarampur village is situated in the Bishnupur 1 block, tehsil of South 24 Parganas district in West Bengal, India. The village is one among the 101 village communities adopted by the Amrita Serve, that is the Self-Reliant Village Program of Amrita. The village is spread over a geographical area of 155.12 hectares, and the Krishnarampur has a total population of 2,787. There are about 545 houses in Krishnarampur village. Methodology. This multidisciplinary experimental learning entails living with the villagers, experiencing their normal daily life routines, and collecting first-hand information on the challenges and resources of the village. This was accomplished through structured fieldwork and using various research methodologies like PRA and HCD. Co-residents with the villagers help the researchers to identify socio-economic problems in the village and understand how they affect the lives of the villagers. This study was conducted based on the ethnographic methodology, where the researchers lived with villagers for 7 days to collect primary data using various research tools from the villagers, and simple random sampling method was used to select the sample size under study. Talking about participatory rural appraisal, PRA, it is a growing family of approaches and methods that allow local people to share, improve, and analyze their knowledge of life and conditions, as well as plan and act. Among various PRA tools, we have used the following 6 tools for our study. The resource map helps to identify the resources and layout of the village. These resources were identified based on the 7 thematic areas such as agriculture and risk management, education and gender equality, energy and environment, livelihood and skill development, water and sanitation, health and hygiene, and waste management and infrastructure of our Living Labs program. A brainstorming session organized with the villagers reviewed their daily challenges in the village. Income expenditure metrics helped us to get detailed information on the economic status of the village, and the inflow-outflow helped to delineate the static and non-static resources in the village, especially the circulation of resources. For the seasonal calendar, we collected information regarding the activities performed during the various seasons throughout the year, and the problem tree helped to compare and validate the identified challenge in the village by analyzing its cause and effect. Moving on, coming to the human-centered design, HCD, it is a process that integrates the user involvement in the inspiration, ideation, and solution implementation phase to rightly understand their challenges and needs. Participatory observation helped the researcher to study the user's behavior in their naturalistic environments to better understand the different tasks performed by the community members in different circumstances. To be more focused on the observation, AEIOU framework was used, that is, activities, environment, interaction, objects, users framework. To collect more information about the user's experience, the team conducted a semi-structured interview session with the villagers during the field study. As mentioned before, the selection of houses was based on a random sampling method, and the persona and scenarios gave an insight into the technographics, psychographics, and demographics, a day in one's life, and pain points with respect to the identified challenge area. Moving on, the result section. This section is divided into 2 subsections, where result 1 includes the result of the methodology adopted that we have previously discussed, and result 2 will be describing the proposed solution and related technical details. So the result 1, from the HCD and the PRA concepts used, the researchers were able to comprehend and analyze the challenges faced by the community, apart from understanding the economical, behavioral, social, and cultural practices of the villagers, and from the various methodologies, we identified the main challenge affecting the community residing in Krishnarampur is the lack of pure drinking water. And the majority of the community members, they work on paddy cultivation and fish farming for their livelihoods. As per the data collected, there are around 18 hand pumps and 100 ponds in the Krishnarampur village. And there are only 2 primary healthcare centers in the Gram Panchayat. For this study, in-depth interviews were conducted with 40 households to understand the problems faced by them. The major non-biodegradable waste generated in the village constitutes plastics, soap, and detergent. The villagers dump domestic waste into the pond, adding to the growth of algae in the pond, due to which people suffer from diarrhea and malaria. Villagers utilize the ponds for washing utensils and other daily chores. On average, they have to fetch water 6 times a day to meet the household water demand. And most of the 40 households interviewed, 36 households use hand pumps as only source of drinking water. And only 4 households among the 40 households interviewed in the village buy purified RO water cans. From the observation conducted by the research team, it was evident that most women of the Krishnarampur village are involved in water collection. And the temperature in the village is hot and sunny during afternoons. Despite this, women along with their children have to go far to fetch water. Thus, improvement in the pond's water quality can prevent villagers from contracting waterborne diseases. This section is the result 2 is further subdivided into 2 subsections, which detail the 2 proposed technological solutions that can address the challenges of the pond water contamination. So the first proposition that focuses on the Jivamritam project, which is Amrita Vishwavidyapeetham Clean Water Initiative for rural India. So the daily drinking water needs of the resident population of Krishnarampur can be supported by one Jivamritam system, and thereby providing safe and clean drinking water to the community. Moving on with the work process of the Jivamritam system. The Jivamritam system is comprised of an inlet tank for untreated water, a motor pump to ensure that water flows through the media at a controlled speed, an electric switchboard for the motors, then a dual sand and activated carbon filter in order to eliminate the suspended particles and the turbidity in the water. And in addition to this, the carbon which is present in the filter, it also helps to reduce the excessive chlorine, the smell which is present in the water, and also some chemicals in the water. Followed by 5 micron and 1 micron filtration filters. And these filters, they filter out suspended particles having size up to 5 micron and 1 micron. And each system also includes an ultraviolet water purifier to eliminate the pathogenic contamination which is caused by bacteria and virus. And last, an outlet tank to hold the treated water. And in order to benefit the community of the people, the output tank will be kept on a tank stand so that the families can come and collect filtered water for their daily consumptions. So solution 2, the Asola cultivation with remote pond monitoring system. From the data that we have collected as part of the methodology, it was evident that majority of the family owned private ponds, and hence water purification could also be obtained by utilizing indigenous resources such as Asola. Asola, especially Asola furiculoides, is a tiny aquatic fern with microphyllous leaves. And Asola is less expensive and can be grown easily with minimal effort. It is also capable of enhancing the water quality by accumulating the toxic nutrients and heavy metals, and it also has the capability of bioabsorption and phytoremediation and nitrogen fixation, and it also helps in good balance of the oxygen level of water. And this nutrient rich Asola, it can be also used as fish, animal or bird feed besides being a good fertilizer. And finally, the quality of water in various ponds can be centrally monitored by an IoT based remote pond monitoring system. This remote pond monitoring system, it comprises of sensors, IoT gateways, and IoT platform. And this smart remote pond monitoring system, it can monitor the conditions of water in real time, and it also helps to mitigate the problems of manual methods of water quality monitoring. And it also automatically monitors various parameters such as turbidity, the pH, the temperature, the dissolved oxygen level in the water, the conductivity, the salinity of the water, etc., which helps us to analyze the water quality. And the outcome from this remote pond monitoring system will also aid in informed decision making, by which the pond owner can decide on when and how much of this Asola feed needs to be added to the water. Conclusion, the residents of the Krishnarampur community, they depend on two sources of water in the village, that is ponds and hand pumps. Even with a total of 100 ponds in the Krishnarampur village, the villages are compelled to depend on the hand pumps that are limited in number, that is only 18 for the drinking purposes for the entire population of 545 houses. So, albeit scarcity of water is not a factor. Actually, the portability of safe and pure water is the issue, whose quality can be improved with the technological intervention, as a result of which we have came up with two solutions to overcome the problem. The first one was the Jiva filtration system, and the second one was the Asola fern along with the remote pond monitoring system, as we have already discussed. Future research will include another visit to village for co-design workshop, a process for understanding, developing and supporting mutual learning between the multiple participants in the village in collective decision making and collective design. These are few references that I have used for making the presentation. And before I conclude, until we lose something, we don't realize its value. And once we realize, it's already too late. So let's save water and maintain its sanitation. Thank you.
Yes, okay. Yeah, thank you very much. Any question for this topic? Yeah, we have time. Any question? No? Do you, hi, Yamuna, right? Do you live
Yes, sir.
in West Bengal for this study?
Yes, sir. We did visit West Bengal just before the lockdown.
Wow, great, great, great. Okay, any question? No issue? Okay, let's go on. Thank you.
Thank you, sir.
Yamuna,
Thank you, sir.
Thank you very much.
Thank you. I think,
yeah, I think, yeah, it seems we move to the last paper, okay? Okay, the last paper is related to the arms delay. Yeah. The author is Olabadi. Okay, welcome. Please.
Good morning.
Good morning.
Can I start sharing the screen now?
Yes, you can share.
Good morning, everyone. My name is Olabode Ido Bismarck, and I'm representing other authors in this presentation. This is the topic of our presentation, the RMS delay spread and channel capacity model for 28 gigahertz MIMO channel with different UE height. And the presentation is broken into introduction, review, material, method, result and discussion, conclusion, acknowledgement, and then references. Because of the explosion of cellular network.
Screen is not visible. Can you just put up your screen? Are you able to share your screen already?
I didn't get you.
Yeah, please try it because we are not able to see your screen.
See me? Can you see me now?
No. I am making you a co-host so that it will be easy for you to share the screen. Now you can try sharing the screen.
Okay. Let me share the screen now. Okay. I think I should just leave the screen like this. So I can now. So because of 4G to meet up with the demand, 5G has been proposed. One of the network configuration for 5G for achieving data rate and network capacity enhancement is network densification, where network densification is talking about spectral aggregation and spatial densification, where millimeter wave is going.
I think Professor Bang, he has some network issues. So I think he's again back. Let's try one last time if he is able to present his work.
Okay.
Yeah.
So you mean we can stop this session?
No, just wait for 2 minutes. Let him complete if he is able to share his screen.
Yeah. We still have time. Yes. Okay.
Olabadi, do you want to complete? You have to unmute yourself. You will have to unmute yourself.
Okay, sorry. You can hear me now.
Yeah, and we can't see your screen also.
Okay. Yeah, can you see my screen now? And you can hear me?
Yes, we can see.
Good. Thank you very much. Yeah, so I was saying that because of the 5G new links, which are in 3D spatial formation, this is unlike the current 2D links where all UE are assumed to be in the 2D plane. In 5G, we are going to have devices in 3D spatial formation, and there are going to be different kind of links, including device-to-device link and all that. These are not available at the current LTE cellular network. Because of this, it is necessary for us to have a new channel parameter models that will be able to handle these upcoming 3D links in 5G networks. One of the parameters of interest is the delay spread. So it is important and necessary to therefore characterize and model the root mean square delay spread of the new 5G 3D links. Delay spread is very important in mitigating intersymbol interference, and it's also important and useful in designing wireless signal receivers. Hello? Okay. Some of the work that are reviewed as shown here, where many authors have also investigated RMS delay spread and other channel parameters. Now, in this experiment, two scenarios are considered. We considered high-rise scenario and the street canyon scenario, where small cells are displayed in 3D formation. And we use beamforming to connect as a backup link to each of the small cells. The small cells on the street canyon scenario are spaced at 1 meter apart. And this is for spatial consistency. And our small cells in the high rise are located 3.5 meters on each floor. The ray tracing algorithm or engine that is used is the Rencom Wireless Insight Ray Tracing Engine, where the 3D map of Lagos Island, Nigeria is used as the propagation environment. Our simulation procedure follows the METIS procedure, where we create the propagation environment, after which we create the communication systems. We create the waveforms, the MIMO antenna for the receiver and transmitter. Then we create the receiver route and also create our study area. We then simulate and then extract the MIMO channel output. One of the MIMO channel parameter that were extracted is the RMS delay spread. In the result and discussion section, one of the things we did is to investigate the distance dependency characteristics and behavior of RMS delay spread. And in the street canyon environment, we see that RMS delay spread has a linear relationship with distance, and the model is shown as 0.4D plus 25.41. Okay, in the high-rise environment, there is a difference in the behavior and characteristics of RMS delay spread with distance or with height. In this case, we see that the arriving multipart component for the high-rise arrives in different clusters, where we have about 3 clusters. These different arriving clusters is as a result of the propagation environment, where the transmitted signal follow different paths, and there are a lot of scatterers where low-rise, medium rise rooftops are reflectors, such that we have different clusters arriving at the high rise. We have 3 clusters actually, and that is why our distance dependency model follows the second order polynomial, unlike the street canyon, where we have single order polynomial. And the model is also extracted as 0.61 L square and all that. The next thing we did was to investigate the probability density function of the distribution of the of the delay spread. And we see that in the street canyon, our model follows a normal distribution, okay, where the model is also extracted using the statistics of the model as shown, okay, in figure 5. Then in the high rise, we see the 3 clusters being shown as the first arriving cluster being modeled as a normal distribution, while the second and the third arriving cluster are modeled as log normal distributions. Their mathematical models were also extracted and presented. After this, we extracted the model statistics. The model statistics are needed and required for reproducing this work, particularly during network deployment. Then the channel capacity that were achieved by our simulation were also extracted and modeled, and the statistics were also presented. Now, when we compare the effect of RMS delay spread on channel capacity, we discovered on our left, the diagram to the left, which represents the relationship between delay spread and capacity. We see that the capacity actually decreases with increasing delay spread, telling us that the lower the value of the delay spread, the higher the capacity that we can achieve. On the right side, we see the relationship between the delay spread and the capacity, and we see that the arriving multipath component, the first arriving multipath component, or the first arriving cluster with the lowest value of delay spread actually have the highest capacity, channel capacity, and then followed by the second arriving cluster and the last one. In conclusion, we see that based on our research work, we can conclude that RMS delay spread is distance dependent, but it's not only distance dependent, but also depend on the propagation environment, because we see that the values increases more where there is no line of sight, as we see in our results. We also see that our RMS delay spread data set fit well with the normal and log normal distribution. And what is the contribution to knowledge for this work? Well, we are able to develop a new set of a series of statistical models for RMS delay spread at 28 gigahertz center frequency and 100 megahertz bandwidth, which are suitable for predicting network deployment in an urban micro cell environment of Lagos Island and similar environments. This work is sponsored by SmartCU, Cookread, and Rencom. Thank you very much. Hello? Hello? Thank you.
Yes, thank you. Congratulations, you finally finished your presentation.
Thank you very much.
Any question? Yeah, any question? Okay. Thank you, everybody.
Yes, thank you very much.
Okay.
Thank you. Thank you.
So if there is no problem, yeah, I would like to close this section. Okay. Yeah. At first, many thanks for joining this section. Okay. I think you should find the scope of these talks is a little bit wide. Okay. However, every speaker's nice presentation, I think.
Okay.
Yeah, I think.
Thank you very much.
You should have have a good harvest. Okay. Thank you very much. Thank you.
Thank you very much.
Bye.
Thank you. Bye. Bye.
Thank you. Bye.
Bye. Bye.
Thank you.
Thank you, Professor. Bye.
Thank you. So, Ami? Hi, Ami.
Thank you.
So thank you, Dr. Pang, for sparing your valuable time to host and chair the session, and we really appreciate your efforts over the time. I wish everyone a safe time because we are again going back with the second wave in many of the countries. And please be safe and be protected from. And my all best wishes to you and your family. I think I'll ask Harsh to just flash a token of appreciation for Dr. Pang.
Yes,
And
sir. Just give me
while
one
Harsh
second.
is doing that, there are a few notes for the authors that we have already moved the data of SMARTCOM 2021 for publication, and it will be approximately 5 months for publication. Till that time, please be patient, and whatever we are receiving from Springer, we will directly divert it to you if there are any queries or any issues. And in the meanwhile, you will also receive a proof copy of your paper, and you will have to confirm that in that automated mail. It will be received by the corresponding author of the paper. So please take a note of that. Whenever you are receiving that mail, please do acknowledge it and complete it as soon as possible to stop delay the time between the intervals. Thank you very much, and this is for you, Professor Pang, and we will be sharing it to you through mail as well as a thanks letter. And we wish everyone be safe during this current times. And thank you very much for trusting our organization and this 5th international conference on smart trends in computing and communication. And we look forward to see you all in Las Vegas next year in 2022. Unfortunately, this year, due to this pandemic, we were not able to make it, but we hope for next year, that is 2022. Thank you very much. And before we just bind up the session, I will request everyone to flash on their cameras so that we can have a picture of it. Although it will be digital, but definitely. So if there are 2-3 participants still available, just you can flash your camera so that we can have a picture of it. I think there are many of them who have already gone. So, Professor Prang, we will be closing this session now. And thank you very much for your efforts and time. Thank you.
Okay,
Thank you very
Bye-bye.
much. Thank you.